I explained what is the angle of repose. The inclined plane, when a body is kept on this, if the angle is small and the surface is very rough, the body will not be moving downwards. When the angle is more than a value, the body will be moving down. What's the minimum value needed? That's what's called the angle of repose. Now here a body is kept on an inclined plane and it is making an angle 60 degree with the horizontal. Body is moving downwards with an acceleration g by 2. You have to get coefficient of kinetic friction. Mass of the body is m. So the gravitational force is acting in the downward direction, that is mg. It can be resolved into two components. This angle is theta. When this angle is theta, this is also theta. So then this can be resolved into two components. Mg can be resolved into two components. This component is mg cos theta. Here it is making theta, so this component is mg cos theta. Perpendicular to that, mg sin theta. Now there is an acceleration along this direction. So we can apply Newton's second law, mg sin theta in the downward direction. Then when it is moving downwards, the friction is kinetic frictional force. When the angle is lesser than the angle of repose, body will not be moving downwards, and then it is static frictional force. Now body, there is an acceleration, so that is kinetic friction. So the force along this direction is mg sin theta. When body is moving along this direction, there is a frictional force that side. Now we can apply Newton's second law because there is an acceleration. So then mg sin theta minus frictional force, kinetic frictional force, equated to mass into acceleration. In this question, angle is given to be 60 degree. So for this theta, we can put 60. So mg sin 60 minus fk is equal to, for a acceleration, we can write g by 2. So m into g by 2. From this, we can get an expression for kinetic frictional force. Take to the other side. So fk, frictional force, kinetic frictional force. Then mg sin 60 we can write root 3 by 2. Then when mg by 2 you take to the side, so it will become minus. So that after rearranging, you will get an expression for kinetic frictional force. In this mg common, so you can take mg outside. Then root 3 by 2 minus 1 by 2. So this can be written root 3 minus 1 all divided by 2. So you are getting kinetic frictional force. So along this direction we applied Newton's second law. Now along this direction there is no acceleration. This is the normal force, and that is balanced by this component mg cos theta. So we can write mg cos theta is equal to n. Here theta is 60 degree, so cos 60, mg cos 60 is equal to n. But cos 60 is 1 by 2. So you can get mg by 2 is n. But you know, kinetic frictional force is equal to mu k into n, where mu k is the coefficient of kinetic friction. Mu k into n. For n, we can write mg by 2. So we are getting another expression for kinetic frictional force. Now here, from these two equations, we can get this relation. Left hand side equal, so equate to the right hand side. So right hand side here, mu k mg by 2. Here right hand side is mg root 3 minus 1 by 2. So mg and mg will get cancelled, 2 will get cancelled. Finally you will get mu k is root 3 minus 1. So this is the coefficient of kinetic friction. When the here angle is given to be 60 degree and the acceleration is given to be g by 2, at that time kinetic friction is coefficient of kinetic friction. Coefficient of kinetic friction is equal to root 3 minus 1. You know that children are fond of playing on sliding boards. If the angle of inclination of the sliding board is greater than the angle of repose, sliding will be easier. But if the angle of inclination of the sliding board is very much greater than the angle of the repose, the slider will be coming down with a greater speed and will get hurt. Thank you for watching.